All right, for this video, we're going to solve log equations. We have three ways, just like we had with solving exponential equations, and they're kind of similar. The first way we're going to look at is canceling logs. So this one's kind of similar to common bases, where if you can get your bases to be the same, then you can cancel them out when you're solving your exponential. Well, now if I'm canceling logs and I can get down to the same log on both sides, then I can cancel them out. So for example, we have log of 4x minus 5 equals log of 2x minus 1. All right, so I have log, remember base 10, because this is nothing written there, so it's our common log. So I have log base 10 of 4x minus 5 equals log base 10 of 2x minus 1. Well, because the logs are the same, if I have log of something equals log of something, those somethings have to be the same. So I can cancel out the logs. And I have 4x minus 5 equals 2x minus 1. And it becomes a simpler equation to solve. So I can subtract the 2x, add the 5, and then divide by 2. So we could say x equals 2. Now when it comes to logarithms, remember you cannot have a negative inside the log. So you've got to make sure that you check your answers and make sure they're not extraneous. So if I take this x equals 2 and I plug it back in, 4 times 2 is 8, minus 5 is a positive 3. And then 2 times 2 is 4, minus 1 is a positive 3. So 2 works fine. All right, for our second example, looks a little bit different. We got log base 2 of x plus log base 2 of 7 equals log base 2 of 37. All right, so now I have three different logs. I cannot cancel them until I get down to just a log equals a log. That's the only way you know they're going to be the exact same. So before I cancel, I need to combine these two logs to 1 so that I have one log on both sides. All right, well, we can use our properties of logarithms, because if I add logs together, I can push them together and condense them using multiplication. So this side becomes log base 2 of 7x equals log base 2 of 37. Now my logs are the same, so I can get rid of them. Right, and we have 7x equals 37. Divide by 7, x equals 37 sevenths. Right, double check. The only x you have to worry about is up here, and this is a positive number, so if I plug in a positive number, then I have a positive inside my logarithm, and it works. All right, now I'm going to erase these, so if you need to, pause and write these down. All right, for part C, we're going to switch to natural log. All right, remember natural log has all the same properties as log. It's just a special kind of logarithm. All right, so here I have natural log of something equals natural log of something, so my somethings got to be the same. So I can get rid of my natural log. And this one looks a little different because now I've got a quadratic. So to solve my quadratic, I've got to set it equal to 0. So I'm going to add the 9 in and add the 2. And now this quadratic we can solve by factoring. I want to multiply to 14 and add to 9, so that's going to be 7 and 2. All right, and then set everything equal to 0. So n plus 7 equals 0 means n equals negative 7. N plus 2 equals 0 means n equals negative 2. All right, now I just got to double check. My answers can be negative as long as what's inside is positive, right? Well, for the first one, both of these are negative, but if I square them, it becomes a positive, and then if I add 12, it stays positive. All right, over here, a negative number times a negative number becomes a positive, right? And then subtracting 2 is not going to make it a negative, so we're good. All right, and one more like this. I got log base 6 of x plus 1 minus log base 6 of x equals log base 6 of 29. So this one's like the second one that we did. Before I can cancel, I have to get down to one log on both sides. So I'm going to have to condense this side. right? And I have subtraction, which goes with division. So this becomes log base 6 of x plus 1 over x equals log base 6 of 29. All right, my logs can cancel. And I have x plus 1 over x equals 29. I cannot solve for x if it's in the denominator. So I'm going to start by multiplying that x over. So I have x plus 1 equals 29x. Now it's simple to solve. So I'm going to subtract the x. I get 1 equals 28x, and then divide by 28. So I have 1 divided by 28. All right, come back up here. 1 over 28 plus 1, 1 over 28. All of those are positive, so 1 over 28 works. All right, so that's how we solve by canceling logs. All right, our second way of solving is by using our inverse function or switching it to an exponential, right? Remember, exponential and logarithms are inverses. All right, so if I just like solving an x squared, I can use a square root, and using, vice versa, I can use inverse operations for exponential and logarithm. All right, so for example, log base 2 of x equals 5. All right, now I'm going to show you two ways that we've done this problem. No, I'm not. We're going to do one way. All right, so if I want to solve this problem, I get down to my log being by itself, so I have to get down to 1 log, right? And then I'm going to switch it to an exponential. Remember, to switch to an exponential, you always start at your base. So my base in this case is a 2, right? And then I'm going to go around the world to the 5 and back to the x. So we've got 2 to the 5th equals x. Well, I can do 2 to the 5th really quickly in my head. 2 to the 5th is 32. All right, remember we got double check. 32 is positive, so 32 fits in there nicely. All right, before when we canceled logs in our first possible way of solving, you had to have nothing but logs. Like you had to have all logs in your equations. In this case, I have a number here that's not a log, right? So that means I can switch this one to exponential. All right. For part B. All right, we got negative 10 plus log base 3 of n plus 3 equals negative 10. Well, before we switch to a logarithm, or an exponential, sorry, I need to get down to this log being by itself, right? Because I got to be able to start at my base, go around the world, and come back. So to start with, I'm going to add the 10. So add the 10 over here. It's going to give me 0. All right, and then I can switch to exponential, right? Now this is one of our special properties, so we'll look at that one in a second. So start at my base, go around the world, come back. So 3 to the 0 equals n plus 3. Well, anything to the 0 power is 1. So 1 equals n plus 3. Subtract the 3, n equals negative 2. All right, we got to double check. If I plug in negative 2 plus 3 is a positive 1, so negative 2 works. All right, now you could have skipped this step in this case because we know if it equals 0, what's in here has to equal 1, but that's one less step of writing. It's not that big of a deal. All right, for part C, all right, just like we did before, I've got to get down to 1 log before I can switch it to an exponential. So I'm going to go ahead and condense these two, and they condense using division. So we can say log of x over 2 equals 1. Right, and then I can switch to an exponential. Now remember, if there's nothing written here, that's our common log, which is base 10. So this one is 10 to the first power equals x over 2. Right, well 10 to the first power is 10, and then I can solve for x by multiplying by 2. So we get x equals 20. Double check, if I plug it in, it stays positive, so it works. All right, and then one more, we'll use a logarithm. All right. So now it's natural log, all right? So then natural log has the same property, same idea. So I need to first condense these, right? So if I have subtraction, that goes with division. So I have 4x plus 1 over 3 equals 5. All right, and then I want to switch to an exponential, but remember with natural log, always has base e. So that means I have a little e here that you don't have to write. So I'm going to start at my base, go around the world, and come back. So I end up with e to the 5th equals this whole thing, 4x plus 1 over 3. Right now, whenever we're working with e, we usually just leave it as e because it's an irrational number. So if I plug it in, I'm going to get a decimal that I round to early. So I'm just going to leave this as e to the 5th and work to get x by itself. So to start with, I'm going to multiply by 3. So I have 3e to the 5th equals 4x plus 1. Subtract the 1 over. So I'm going to come up here. Let's this over a little bit. So I have 3e to the 5th minus 1 equals 4x, and then divide by 4. So we get 3e to the 5th minus 1 over 4 equals x. All right. And then you can kind of do a little mental math. If I were to plug this back in, the 4's cancel. So I'm left with 3e to the 5th minus 1 plus 1, or in other words, 3e to the 5th. And that's going to be 3 times 2.7 to the 5th, which is positive. All right. And then our third and final way of solving logarithms, just like with exponential, we can use a calculator. All right, and by using a calculator, I mean, I'm talking about we're going to graph it and find where our graphs intersect. So we're only going to do a couple of these. So our first one, log base 3 of x equals 4. Right? When we do this on the calculator, you don't have to do anything to your equation. You don't have to do any condensing or anything. All you do is take whatever's on the left and whatever's on the right, and we're going to put it in y1 and y2. All right, so I'm going to bring up my calculator here. Zoom in. Oh, gotta get out of this mode. Let's go back to function. All right, so in y1, right, remember if I have a log, anything other than our common log, we go to math and go to capital A. All right, so now I've got log base 3 of x. And then here I just have 4, so that's going to be a horizontal line. All right, let me go to my standard window. And I just want to make sure that I can see that intersection in my window. So this first one, when it graphs, I can't see where it crosses. So I'm going to zoom out. All right, and I'm going to zoom out one more time just because I don't know for sure if I can see it in that window. But this one should work. Doesn't have to be pretty. All right, and I'm going to go find the intersection. So second trace, intersect, right? First curve, second curve, maybe. Does it say y1? There we go. Oh, let me go this way. There we go. All right, so it looks like my intersection is at x equals 81. All right, which makes sense because we've got log base 3, so 3 to the 4th power, which is 81. All right, and that's the gist. So we'll do one more of these. Oops, not log base 3. Log of x plus log of 8 equals 2. All right, and just like before, you don't have to do anything except y1, y2, just like it's written. So I'm going to go back to my y equals here and zoom back in for you. I'm just going to leave this one here. And well, actually, since we're doing common log, I'm just going to use the log button. So we got log of x. All right, I'm going to close that parentheses. There's plus log of 8. And then this equals 2. All right, and I'm going to go back to Zoom standard to see if it's in that window. All right, and it looks like it crosses, so we'll try. So second trace, 5. All right, And the first time I did this, I had an error because remember you have an asymptote here, and not really an error, but it wouldn't pick up on that first graph. Remember your logarithm has that asymptote. So I'm going to scroll to the right a little bit, then it'll let me choose that first curve, and then second curve, and then tell it to guess. Oh, so that means it's not in that window. If you get an error, that means that you just don't see your graph or your intersection in that graph. So I'm going to zoom out, let it load, and we'll try it again. So second trace 5, I'm going to scroll this way a little bit, enter, 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 and we get x equals 12.5. All right. All right, so you can cancel your logs if you have nothing but logs in your equation. So if you have all logs, you just get them down to 1 on both sides, cancel them out, right? Then if you have some logs and a number, right, then you get down to the 1 log on one side equals that number, switch it to an exponential. And then your third option is to take the left side in y1, right side in y2, and find where they intersect. All right, and that's how we solve our log equations.